Good morning, everyone, or good afternoon, depending on where you're joining us from, and welcome to today's webinar. I'm Cess, your moderator from Business Review, and it's truly a pleasure to have you all here. We're delighted to have our wonderful sponsor, Donaldson, with us today, who'll be presenting this webinar titled Unlock Operational Efficiencies in Beverage Manufacturing. Let me introduce our esteemed guest speakers for today. Our first speaker, Dominic, Manager of Business Development for Non-Alcoholic Beverages. Dominic joined the company in 2019 as an application engineer in the product line Process Filtration in Germany. He was responsible for the product range of sterile air and liquid filters used in food and beverage applications, supporting both customers and the Donaldson sales team with technical know-how and on-site support. And our second speaker, Scott, Global Process Manager. Scott has more than 30 years of experience as a filtration expert. He joined Donaldson in 2014 as a regional manager in both the US and Canada, responsible for sterile filtration in liquid and gas applications across multiple markets, including pharmaceutical and food and beverages. In 2016, Scott moved into SME role responsible for OEM and engineering firms working to specify sterile filtration used in the pharmaceutical and food and beverages industry. Now, before we dive into the content, let me take a moment to familiarize you with our webinar platform On24. This webinar is browser-based, so if you disconnect for any reason, simply click on the link provided in your email to rejoin the session. Additionally, today's webinar will be recorded and available on demand access. It will also feature 3 polls, and your participation in these polls is not only encouraged but greatly appreciated. So I urge you to take a moment when the polls come up to share your thoughts with us. Should you have any questions during the presentation, feel free to use the questions widget. Just type them into the box located at the top right-hand corner of your screen and click submit. We'll set aside some time at the end of this session to address your queries. For any technical assistance, the yellow help widget is at your service, and you can adjust, resize, and maximize any of the windows in front of you for a better view of the slides. But now, without further ado, let's extend a warm welcome to our first speaker, Scott.
Thank you, Cess, for that kind introduction. Additionally, I want to thank all the participants for attending today's webinar on unlocking operational efficiencies by optimizing your filtration process. During the next 30 to 40 minutes, Dominic and I will walk you through several key factors such as market trends, how Donaldson defines operational efficiencies, contributions an optimized filtration system can have on your process, case studies that help elevate this into best practice, and lastly, a pathway on how to achieve results. Before going further, I want to make a quick review of current market demands in the beverage industry. Sustainability is a very important topic. There are important conversations surrounding reduction in water and energy consumptions, and of course, landfill waste. There are also market drivers from the consumer which have the appearance of being more relevant. Consumers are looking for brands that resonate with their own individuality and ideas centered around being a conscious consumer, such as clean ingredient labels. An example would be functional beverages that provide additional health and wellness benefits. Steering the conversation back to sustainability, let's break this out into parts. First, how much water is being used to manufacture your product? This then leads us to examine the overall usage of fresh water and tools on how to reclaim or recycle this water. This can lead to potential savings in energy and reduction in waste. Later in this presentation, we will have a case study that looks at this from the perspective of a CIP system. But before we go any further, I'm going to pass us back to our moderator, Seth, for our first poll question.
Thank you, Scott. All right, folks, our first poll is now live. And the question is, who is responsible for the measurable impacts of operational efficiencies in your plant? A, maintenance manager, B, production manager, C, quality manager, D, all of the above, or C, or should I say E, I don't know. Please take your time to carefully consider each option. If you need a moment to think, feel free to do so. Remember, your input is incredibly valuable to us, so take your time to ensure your responses reflect your thoughts accurately. All right, thank you everyone for participating in the poll. Your input is truly appreciated. Now let's quickly take a moment to review the results together. Okay, fantastic. Well, I'll pass it back to Scott to continue his presentation.
Thank you, Seth. And to those who answered our poll question, I'm very happy to see the results. So let's look at operational efficiency. Here at Donaldson, we define operational efficiency as having the ability to reduce waste in time, effort, and materials as much as possible, while still producing high-quality services and products. This all must be done within the strict guidelines and regulatory demands, both internal and external. To help unpack this concept a little further, I'm going to pass this over to Dominic, who sits in our manufacturing location in Hahn, Germany. Hi, Dominic. How are things today?
Hello, Scott. Yeah, things are very good in Germany. It's very sunny today. So yeah, let me also welcome everybody to the webinar today from my side. And as Scott already mentioned and introduced our topic of today, operational efficiency, we want to break down that concept a little bit more. So how do we reach efficient operations in our productions? And we categorized here into three big groups: the process, the technology, and the people. On the process side, first, we need to build all of our installations with efficiency and efficient design in mind from the beginning. And that usually also leads to concepts like automation or standardization, because only with automation and data collection, things like predictive maintenance and downtime planning become feasible and much easier. On the technology part, of course, we need to invest in state-of-the-art technology to keep up with those demands of the current industry, while still keeping a very close eye on our total costs of ownership, or TCO. And probably one of the most important factors in how to reach operational efficiency are the people in our plants. They need to have the necessary training and the necessary know-how to perform as efficient as possible. And all the necessary services, be it first-party or third-party services, need to be in place. So the concept I just showed is basically applicable to all of your process equipment. And in the next chapter now, we're going to look especially on how to apply that concept and those principles onto filtration. So what is filtration's contribution to operational efficiency? But before we go a little bit more into detail here, we want to know a little bit more about your filter installations. So we do have actually another poll question coming up right now. Seth, please.
Yep, thank you, Dominic. Here's our second poll question. Think of the filter installations at your plant. Who designed them? A, always to say OEM, B, different sources, historically grown. C, we did it ourselves. And D, I don't know. If you're not sure, I'll give everyone a minute to access the poll and submit their responses. Again, please take your time to consider your answers carefully. Once everyone has had the chance to respond, we'll continue with the presentation. Great. Well, thank you to everyone who has participated. Now let's take a moment to review the results. Wow, fab. It's fascinating to see a diverse range of perspectives. Now, if you do have any additional comments or questions about the presentation topic, please feel free to use the questions widget. We'll set aside some time at the end of the session to address your queries. Now, back to you, Dominic.
Thank you, Seth, and thank you everybody for answering that question. I think what we see here, that different sources and historically grown is the key or most clicked answer here is very representative what we see all over the world. Because most filtration installations have historically grown and were not really designed with all the influencing parameters in mind, which you can see here maybe on the slide. Because there are so many critical parameters we need to take care of when we are implementing a filtration solution. The one most people think about is the filter lifetime. A filter needs to last as long as possible. So filter lifetime is very important for us to keep our TCO, our total cost of ownership, in check. And that usually also means we need to have low differential pressures, which are mandatory for low energy costs. But there are many other connected resources that we also need to take into consideration when we are talking about total cost of ownership. The filters may need to be cleaned with chemicals, or they need to be sterilized with steam or ozone. And every single of those steps will come with labor. And labor also contributes to your total cost of ownership. But most importantly, we can now optimize filtration installations for cost savings as much as we can, but they are still a critical food safety control point for your product and process integrity. And that is because they are removing those bacteria, they are removing those particles from your product or process. So filter retention efficiency is a very important factor and a big contribution and support to your product and process integrity. Which basically leads us here to the last point of certifications. Because filters first need to come with all the relevant certifications for your process or industry, like food compliance or a quality certificate. But they also can support you in complying with local or global regulations for your type of industry. So what I want to do is I want to pick some of those points and go a little bit into deeper to see what the actual impact is we can have on that. First, we can have an impact on resources. So probably many of you know about the influencing parameters for cleaning equipment with chemicals, the so-called CIP process. Because to create an efficient cleaning process, you need the right temperature, the right contact time, the right concentration or type of chemical, and you need a mechanical process of having a contact with your cleaned surface. So that means you either increase the temperature, the time, or concentration to increase your cleaning impact, which means you will increase costs. And if we now look at, for example, liquid filtration, those can usually be regularly cleaned with CIP steps. So once they have built some differential pressure, then you can do a CIP process and that differential pressure can be reduced again. So the key now for most efficient and cost-saving cleaning processes is to make data-driven decisions. Because as you can see here, cleaning is much easier when the element is still fresh and new and the differential pressure is not as high. But the more differential pressure is built over time, the older an element gets, it will get much harder to clean that element, and you need more CIP effort to get a reasonable cleaning result. So only if we know this type of data and we're tracking this type of data, then we can incorporate connected resources like CIP, the water, the chemicals, into our efficient filtration designs. The next one here is impact on energy. And I want to tailor this a little bit more to compressed air installations. So here we really want to focus on your compressed air lines, because compressed air lines, they tend to have much unnecessary energy loss that can actually be addressed. First point here is leakage control. Any small leakage in a compressed air line can create an energy loss, and that can be directly calculated to a cost loss per year. So you can see here an example in the table of a 1 square millimeter leakage. So imagine you have multiple of those leakages across your line and they are not attended. So that can lead to quite a big cost impact per year. So regular leakage controls are mandatory for an efficient compressed air line. Also, any pressure loss or differential pressure in a filter installation correlates also directly to an energy impact. And there's kind of the rule of 1 bar of differential pressure in your line will roughly translate to 10% higher energy demands. So I think all of this shows pretty much that we need to investigate all those operational efficiency parameters we showed before, the process, the technology, and the services to address the efficiency. And as a last detailed point here, I have impact on waste. Because when we're looking at your KPIs on waste, this starts usually with the manufacturing sites of your filter supplier. Donaldson, for example, we follow this cradle to grave product sustainability impact process. And through this process, our development teams of filters try to better understand from the beginning and quantify the sustainability impact of product design decisions throughout a product life cycles. And this life cycle, it begins at Donaldson with the right material and process decisions, but it continues to our customers with the inline performance and end-of-life considerations. So basically, as we showed before, we need to achieve high lifetimes and make data-driven decisions to reduce the amount of downtime and waste, which results when we need to change our filter way too often. So rather than changing low-cost filter element every week, we should aim for longer changeout periods with more premium filter and measuring the cost impact not by the price of one filter, but with the total cost of ownership in mind. So I think this was a little bit of a deeper look now into efficient filtration design, and Scott will now walk us through some real-life example and some case studies. So please, Scott.
Thank you, Dominic. Let's take a look at 4 separate case studies that I think directly relate to what some of the items Dominic was just mentioning. Our first case study really speaks to the reduction of waste, but also helping to improve filtration performance. Our first case study is from a global beverage manufacturer who approached us concerning a problem they were having with their RO membranes. Their RO membranes had not been meeting the typical life cycle benchmarks in life performance, even with the current pre-filtration steps in place. Using our regional service teams, we conducted tests on the facility's incoming water using common methods. For example, a silt density index test was performed here at this site and determined that the total suspended solids levels were way too high. This led to a process improvement project on the RO's pre-filtration step. So pictured here is the exact drawing of the solution Donaldson provided. As you can see, it is a manually operated but yet integrated system that we installed high surface area filter elements, commonly known as high flows. The important thing here is that it provides exceptional flow characteristics and dirt holding characteristics, and ultimately much longer service life. And the most important topic is that it provided the needed protection to the reverse osmosis membranes. This functionally led to very long service lives and ultimately increased protection to these membranes. Outcomes here, as mentioned on the slide, are reduced costs and waste. The next case study is something that I've spent a lot of time on, and this is pasteurized equivalent water. Now, it's been popular within the dairy industry for many years. Now we are hearing from other beverage manufacturers on the same topic. This question is, or the question is, how can I reduce the load on my pasteurizer by using alternative means? It is even more important to seek alternative means from traditional pasteurization when we look back at consumer trends that I mentioned earlier, specifically at functional beverages that have ingredients that are not heat stable or do not survive UV disinfection methods. Standing out as a possible solution is microfiltration. When using select dead end or full flow filter membranes that have specific microbial retention values, and then integrated into a fully automized system like pictured here, can help provide twofold benefits: targeted energy reductions and savings in time without sacrificing product safety. Next, we're going to look at the concept of water reduction. Now, you may recall I mentioned this particular case study. Recovering and reusing cleaning solutions from clean-in-place systems is an effective method to optimize spend and reduce environmental impact of that CIP process. Reduction is the key concept here. Reducing energy consumption by recovering your secondary rinses then can lead to savings in makeup water and chemical feeds. There's also the potential for the reduction of effluent from your facility. Pictured here is a manifold filter system utilizing Donaldson's backwashable LifeTech PGSLN filter elements. These filter elements are made of 100% stainless steel and are used to reduce solid levels before reclaiming, reusing, or further processing CIP solutions. By using 100% stainless, we can provide an efficient and robust solution that is not susceptible to typical CIP temperatures and pH values. This leads us to realize reduction in waste and overall reduction in total cost of ownership. Saving on resources. Dominic had mentioned about compressed air, and so I'm going to kind of continue with that theme. Using ozone as an agent for sanitization is very effective, especially when there is a need to produce an aseptic environment, such as found in a buffer tank. Ozone production can require compressed air. This compressed air usage can be reduced when using an ozone-resistant sterile-grade filter element like Donaldson's LifeTech PSRF-B cartridge. As a standalone, this cartridge, or when used in combination with ozone, can provide optimized solutions for maintaining sterility. And again, this would be typically in an aseptic environment. And as I mentioned earlier, this buffer tank is a typical application. This optimized solution affords increased protection to product and product contact surfaces, and the implied energy savings by reducing demand on your compressed air system. Now I'm going to pass the presentation back to Dominic for our last chapter, and that's, what does a roadmap look like? Dominic,
yeah, thank you, Scott. Thank you. So yeah, let's look at your road to operational efficiency in filtration. So how can we now optimize and start contributing to those KPIs? So first, I want to introduce you, of course, to our Donaldson teams that are supporting you on this journey. At Donaldson, we do understand the importance of process optimization and maintaining the efficiency of filtration systems with our subject matter specialists, like Scott and myself. We are providing that training and best practice, and we are in close contact with over more than 100 of our local support teams who are supporting our customers directly around the globe. Additionally, we are aligning global key accounts worldwide with our strategic key account team. So they are aligning on and sharing the most efficient filtration solutions and the know-how necessary to implement them. And when it comes to services, Donaldson does support our customers with our field service team, and they are proficient in, for example, ISO 85731 compressed air quality class audits, or doing leakage control tests, as we have seen before. And they are also helping our customers to implement filter management systems, which may also include integrity testing. And additionally, we do have on the right here our system integration team, because as a filtration expert, Donaldson also provides both plug and play and custom filtration systems via this team. And they are designing those solutions with efficiency in mind from the beginning, which is, again, very important for the process. So what you can see on this slide here is a very simplified workflow, how we're usually starting to execute those optimization processes. The first thing in identification, we are trying to align with you and about the plants and sites and maybe product lines with both the most opportunities for improvement or maybe even risks for your product and process integrity. Maybe some of them have historically grown, as we have seen in the poll question. So maybe we need to address those first. And then we perform what we call a technical site assessment. And we're using our subject matter experts, but also our local team and our service team during these site assessments. And we look at ways to support the integrity and efficiency of your production process and compare all filter installations to the filter best practices in our experience. After the site assessment, you will usually get a full site assessment technical report, and that report will include an action plan, and that action plan will be prioritized. Each of those findings will be prioritized for you, and then you can execute those individual projects for improvement of optimization or addressing certain risks on a local level with your local Donaldson contacts. And on the next slide here, I want to demonstrate this a little bit on a very simplified example you see here. So what you see here is a simple bottled water filling process from source to filler with a media bed filter in the beginning, like in reverse osmosis system with a pre-filter, some storage tank, and then a multi-stage filtration before the filler. And there's also a CIP system in this one. And even in this very simplified example, we want to just highlight some of the recommendations you would receive out of a Donaldson site assessment. For example, here in blue, we could look at the liquid filtration cartridge choices. And we can find opportunities to improve lifetime, to decrease differential pressure, and to optimize your combinations of filters, especially if we're dealing with multi-stage filtration systems. And here in this example, we maybe have an open storage tank, an open buffer tank, which is a risk for recontamination after you have gone through extensive reverse osmosis treatment already. And we talked a lot about the compressed air lines. So we can start optimizing in terms of energy reduction, in terms of ozone reduction, and resources. And Scott has already shown the CIP purification or CIP recovery system before in the case study, so we can also look at CIP savings. And once we have addressed all this, then here you can see possible implementations after a site assessment. So they are, for example, addressing all potential risks with state-of-the-art filtration solutions, reducing the resources and energy consumption from source to application on your compressed air line, saving on CIP resources with a CIP recovery system, and optimizing this filtration lifetime and reducing your overall TCO and downtime by performing, for example, filterability tests at your liquid stages and finding the right optimized filter combinations for your type of water or product. So before we close this out now with one last poll question, I want to give a final overview over the offerings and portfolio of Donaldson. So Donaldson does offer all the relevant filter elements for liquid, gas, and steam, and we branded that as our LifeTech filter portfolio. And we do offer for compressed air and gases all the equipment necessary to achieve certain ISO 85731 classes from the compressor to the point of use, including, for example, fridge dryers or absorption dryers, and also all the connected services. And finally, we have already talked about our system integration team, which are offering those plug and play and custom systems, which can fit very well into your process. So yeah, before now Scott closes out this presentation for us and we can address some of your questions, I want to give it back to Seth for one last poll question.
Thank you, Dominic. And here's our final poll for today's webinar. How many individual filter installations do you totally have in your liquid, in your plant, liquid, air, and steam? How many individual filter installations do you have? 1 to 2, B 3 to 10, C greater than 10, or D, you are not sure. We'll take a moment to let everyone have a think and interact with the polls before I hand it over to Scott to close the presentation. Okay, thank you to everyone for participating in the polls. Again, your input and engagement has been invaluable and very much appreciated. Now let's take a moment to review the results. And here they are. Wow. Great, another intriguing set of results. Now over to you, Scott, to close the presentation before we start the Q&A.
Thank you, Seth, for your help today, especially for administering our poll questions. Much appreciated. So, the key word here is imagine. Whether you're a local or a global producer of beverages, there are savings potentials available to you when you dedicate time and resources to achieving filtration optimization. Whether you're looking to reduce artificial load on your process utilities, like compressed air or your steam system, or increase filter element lifetimes or reducing water usage, Donaldson, with its 100+ year history, is here for you. We bring innovative filtration solutions to your facility through a very personal, collaborative process that we have designed to make sure that it benefits you and your company. We here at Donaldson want to thank you for your time today. Now let's turn things back to Seth for our question and answer session. Thank you.
Thank you, Scott, and thank you also, Dominic, for your informative presentation. Now let's dive into our live Q&A session. Just a quick reminder for the attendees. You can input your questions by clicking on the questions widget and typing them and submitting the questions straight to us. All right, so got some interesting questions here already from the attendees. So I'll start things off with this first question. How do we request a site assessment and how much does it cost?
Okay, yeah, I think I can answer that because we actually, we did not mention that. That's true. So first of all, the logical way is to contact your local Donaldson contact person if you are already in contact with Donaldson. If you're not in contact with Donaldson, we have here on the screen actually the CAP-Europe email address, which kind of summarizes and gathers all the requests for site assessments for us, and then distributes it out to the local teams, involving also those sector specialist team and those expert team and the services in the regions. So yeah, I would appreciate, especially for the people here in this webinar, if you want to request a site assessment, please use this email address, and we will be able probably to offer you a free site assessment for the first time.
Perfect. Well, thank you for that, Dominic. Another question that we've got is about the RO membrane. Earlier, you mentioned the life cycle of RO membrane. What is the typical industry benchmark for lifetime? Is an RO sterile?
Yeah, I can take that one.
Question?
Yeah, that's good. That's good. So historically, in beverage manufacture, where we're looking as water as the main ingredient, with proper pre-treatment of the incoming water into the RO membrane, I've seen RO membranes go 4 to 5 years. And to answer the question is the effluent or the permeate off an RO membrane is sterile. So reverse osmosis membranes have the ability to remove organisms of concern, but you really can't validate it or steam sterilize it. So in my world, I don't consider it sterile. We would put downstream of the RO membrane a select dead end style polyether sulfone membrane at maybe 0.2 micron to achieve that validatable sterile microbiological barrier. I hope that answers the question.
Yeah, I would also 100% agree with that. I would not consider a reverse osmosis membrane a food safety control point, because you kind of need a testable and steamable filtration at the end to achieve that sterile water quality. Yeah.
Thank you both. We've got another interesting question here, and this is about the, I believe, cartridge filter. So what is the maximum drop pressure for a cartridge filter and for a tank filter?
Okay.
Dominic, why don't you take the first part of that?
Yeah, so the maximum pressure drop, it really depends on the type of cartridge, first of all. But if we are talking, for example, a liquid filter installation, like a water filter, I would never run them above 1 bar of differential pressure usually, because as we have seen in the CIP cycle detail, it will get much more difficult to clean it efficiently. So I would rather stay below 1 bar differential pressure, but it depends, of course, on the application. Sometimes you can run a little bit higher, but if a filter achieves 1 bar, it will usually achieve 1.5 bar very quickly because it's an exponential kind of blocking curve. So once it's above 1 bar, you know that filter is going to reach end of life, or it will definitely need cleaning. So depending on if a CIP system is in place or not. For compressed air, this depends again on the filter type. If it's pre-filter, they are usually measured with differential pressure, and we have clear recommendations when to change them. If it's a sterile filter should actually never really block, because it is only dealing with the bacteria, with the final contaminations of bacteria at the end. So it should never see too many particles and block. So yeah, very, very dependent on the filter type we are talking about here. And for tank filters, maybe you, Scott, wanna mention something?
So on tank vent filters, they really need to be sized for what is the allowable differential pressure on the tank. Usually measured in millibars, very, very low. This sizing step that is mandatory really needs to take into consideration what is the collapse pressure or the max differential pressure the tank can hold. And again, typically this would be measured in millibar. If you have the individual asking this question, if you want more detailed explanation, please just reach out to us on the email address provided on the screen. Next.
Thank you both. Yep, and sticking to that topic, I've got another question here. What is the difference in differential pressure compared to local filters in percentage? I'll ask that again. So
okay, I'm a little confused on the concept of local filters.
I mean, there are definitely differences in filter designs across filter manufacturer. Maybe that is meant here, that a local filter supplier or something is offering a filter cartridge. There's going to be big differences in differential pressure over time. So in percentage, that's a little bit tough to say because we need to know again which type of filter we are talking about. But the filter, cartridge design plays a big role in how to address that differential pressure and how to keep it low for a longer time.
Right.
Maybe.
Yeah, I would say there's a difference in flux, in loading capacities, and then on the design level, using pleated filter media is the best possible way physically to increase filter life and lower differential pressure. As an example, in our steam filters, we have two different offerings. We have that PGSLN that I mentioned earlier, which has double duty in both steam and liquid, and then we have a sintered material, which is more of a surface filter. The differential pressure comparison between the two is in excess of 40%. Obviously, the pleated filter is 40% lower in differential pressure in the identical application. So that's just one example between pleated filters and a surface filter. I hope that provides some clarification. Thank you.
Thank you both. And another reminder for the audience, you still can ask your questions using the questions widget. Moving on, we've got another interesting question from the attendees. Will Donaldson offer replacement RO membranes as drop-in replacements for competitor RO systems?
Dominic, you can answer that one.
Yeah. So currently Donaldson has no plan of replacing RO membranes. We are a microfiltration focused company. So all of our filter systems, including the high flows we have seen, including the sterile air filters or the liquid filters, all fall into the microfiltration range. So this is where we are focusing on. This is where we are the filtration experts. So currently Donaldson really has no offerings in terms of RO replacements, but we do know about RO membranes because we are offering those pre-filters for RO systems. So yeah, it always plays together. If you have an RO system, it always comes with a pre-filter, and if you need to achieve sterile levels, it needs to come with a follow-up food safety control point at the end. So yeah, that would be my answer here.
Great, thank you for that. Another question that we've got here is a two-parter. So you mentioned a back-flushable stainless steel filters. What micron size and efficiencies are they available, and how long do they last?
Dominic, I think you can answer that one.
Yeah, sure. So we're talking about the LifeTech GSLN element. I think that is what the stainless steel element here is meant. And we showed that in the CIP recovery case study. What micron sizes and efficiency? So we have it available from 250 microns as our biggest size down to 1 micron. And the efficiency is 99.98%. And some of you may know more like beta values, beta ratio values. It's a beta ratio of 5,000 for them. So they keep away 99.98% of the stated micron sizes. And the second part was, how long do they last? So that's the good thing about stainless steel elements. They are really 100% stainless steel. There is almost no degradation. And they can be cleaned very efficiently, again, with backflush, with chemicals, but also with ultrasonic baths. And you can almost get them as new as they were in the beginning after a cleaning. So they can definitely last you 2 years and longer. Again, depends a little bit on the application they are being used in, but usually you can definitely calculate your return of investment based on something like 2 to 3 years.
Thank you, Dominic. And I'll ask this final question to end the live webinar. So you mentioned integrity testing services. Is this applicable to pasteurized equivalent water solution you have showed?
Yeah, I can handle that one. Absolutely. The important thing here, and I don't want to drag this out too far because we can really go into a lot of detail, but you want to make sure that you have a filter membrane management program. First and foremost, that you're sourcing a filter membrane that is specific to your organisms of concern and has been pre-validated by the supplier. And then when it gets into your facility, you want to test that integrity. And so we have portable devices that you can do this on-site, online integrity testing. Typically, it's known as a pressure hold test, but our device is capable of doing much more. In addition to that, our laboratory services, whether it be in Europe or the United States, has the ability to assist you in doing some of that testing, kind of in more of a post-mortem kind of application. I hope that answered the question. Thank you very much.
Thank you very much, Scott, and thank you also, Dominic, for your excellent responses. As we're near our scheduled time, we'll now have to conclude our live Q&A session, but please don't worry if your questions haven't been addressed, as we'll follow up with you in the next coming days. And that brings us to the end of the webinar. I'd like to express my heartfelt thanks to Dominic and Scott for their outstanding presentation, and to our sponsor, Donaldson, for making this session possible. To our attendees, keep an eye out on your email for instructions on accessing the on-demand version of this webinar. You can also find it on our website, www.pmi-live.com. Stay connected with us for more exciting webinars. Follow us on X at BR Webinars, and join our LinkedIn group, Business Review Webinars. Once again, thank you for joining us today, and I wish you all a wonderful day ahead.
Thanks, everyone.
Thanks, everybody. Bye.